many of you have come to Devday for the first time? Just a show of hands. Oh, quite a lot. So I think just a quick introduction about Devday and our company Sahaj. So Devday is a informal gathering where we sort of get speakers from different from the community in Chennai mainly, the tech community, to come and speak about any topics that are sort of friendly or useful for developers from a technology standpoint. So Devday is run by Sahaj. I am from Sahaj. We are all based part of an organization called Sahaj Software. We are basically a niche consulting firm, software consulting. We work on mainly areas around distributed computing and making inroads into data engineering, AI. So I think I'll hand it over to Mohan now to speak on microVMs and the journey from VMs, containers, back to microVMs.
All right, people. Hello. So I'm also going to start my talk with a show of hands. How many of you have used Docker before? Almost half of you. So how many of you have used Kubernetes? Okay, half of that. So how many of you would say you have had extensive experience with Kubernetes, like at work or hobbyists? One person. Awesome. So if I make some mistake, please correct me. So yeah. So for context, if you thought this was going to be like a intro to containers talk, I'll try to keep it that way because since a lot of people don't seem to have the context of Docker and containers. So who am I? My name is Mohan. I work for this company called Avalara. I'm a software engineer at Avalara, and I've also been, so am I audible to everyone? Okay, so I work for a company called Avalara, and since 2017 I've also been organizing the Docker meetup. And the Docker, the Kubernetes and all these projects, they come under a umbrella organization called CNCF. You can think of it like Apache Foundation, but it's like it's a newer version of that, let's say. So a brief introduction about the company that I work for. So Avalara is a company that tries to make tax compliance easy, and by tax I mean the sales tax and the kind of tax businesses pay, not the income tax. So we are a fintech company, and we do not only taxes, we do a lot of other transaction-based tax kind of things like tariffs. Like if you're trading between countries, you pay tariffs instead of taxes, import duties, export duties, those kind of things. We do that as well. We are a fintech company, and but primarily we do sales tax because in India, if you talk about sales tax, it's GST, right? It's pretty simple, but in the US, it's pretty complex. It's very, very complex. In fact, it's a 5-dimensional problem. The amount of sales tax you charge for an item, it depends on a lot of factors like where, when, how much, and whom do you sell to, all these 5 WH words. So some of these dimensions are more complex than the other. Like when you sell it is something that you can very easily determine, but the amount of tax that you need to charge depending on what you're selling and where you're selling is very, very hard because there are a lot of variations. So my team, I used to work for this company called Index, and we used to have the largest product database. We used to crawl Amazon, Flipkart, and all of these e-commerce sites, as well as the brand sites like Nike and Adidas and all these sites, and we had a indexed product database. We had more than 2 billion products, close to 3 billion products. So Avalara acquired us in order to enrich their product database essentially. So of these dimensions, 2 of these, what and where, are really hard. So in order to tax something, you need to know what you are selling. If you are like a third-party seller, you wouldn't know you would know what the constituents of your product, the product that you're selling is, right? For example, I'll give you an Indian example. If you're selling recently, let's say 4 or 5 months ago, the tax on caffeinated drinks was increased from 28% to 40%. Came out on news. So caffeinated drinks are taxed at 40% in India. So how would you know if your drink is caffeinated? Like if you're someone like Amazon or Flipkart, how would you know that your drink is caffeinated, right? You wouldn't. For example, Coca-Cola is caffeinated, but Mirinda is not. So you need to tax Coca-Cola at 40% and Mirinda at 28%. But you wouldn't know because you're a third-party seller, right? But we would know because we have the largest product database. So we have all the attributes standardized. So we would know that, and that's what like otherwise, if you didn't use Avalara, what you would do is you'll manually go read through your products descriptions and then like find the appropriate tax code, right? You don't have to do that if you use Avalara. And var is like even a messier case in US, which is actually like nice for us. In the US, you have different tax codes for different jurisdictions. Like for example, the tax here in India, if I buy something here and across the street, the tax would actually be the same. You cannot make that guarantee in the US. There are cases in the US where things are taxed at 1% on this side of the road and it's taxed at 8% on the other side of the road. And also in the US, every local jurisdiction also has the authority to impose its own tax. Let's say you have a local municipality and the municipality wants to construct a new school, they can just raise a 1% tax. So if you live in that municipality, if you have a shop in that municipality, you will have to collect that 1% extra tax. And the only way the municipalities actually notify is through their website, right? So there is no centralized place from which you can go get these tax rate changes and tax rate information. So we also handle that. The team in Chennai, which was former Index, we also handle that. We use the same technique that we use to crawl product pages. We use the same technique to also acquire sales tax information. So these are some numbers about the company. Like I said, we are a fintech company. So $36 billion worth of taxes went through us in 2018. That number, it's close to double that this year. And the way Avalara gets all these transactions is through a number of ERP integrations. If you know an ERP integration, I'm pretty sure there is an Avalara plugin for that, because I was surprised. I joined this company very recently. I was surprised that even the ERP systems that I've never heard of actually had an Avalara integration. And these are some popular ones like Square, Wix, and Shopify. These are big names. Even a lot of our volume comes through this. And we process 1.1 billion transaction every month. So that's like nearly 15 billion transactions a year. Those many transactions actually go through Avalara. And you might have actually used Avalara already indirectly. If you have bought anything through the Amazon Global Store, that actually uses Avalara. So it would have used Avalara to calculate the tariffs for shipping into India. So let's get to the talk. So this is a brief introduction of virtual machines. So in the beginning, there was, there were a lot of IBM computers. Back in those days, you didn't go to a shop and just buy a computer, right? Computers were big business and they were specifically made for organizations. But IBM had like a few standard models, and at one point they wanted to like unify all those models. They had 1401 for commercial calculations. They had one model for scientific calculations. They had multiple competing verticals, and a customer, let's say if you are a prospective customer, you had a lot of models to choose from, and in many cases you had to buy multiple models. Okay, so this was not a very good place to be in from a sales and marketing perspective. So they introduced this new system called IBM 360, which was System 360, which was supposed to revolutionize the whole game. But the problem was people had to rewrite their software, like recompile their software for IBM 360. Back in those days, you didn't have you didn't actually have a high-level language like C. You had to write, programs were written in assembly code, right? So the assembly code for the older IBM systems and the new IBM system was different, which meant a lot of people didn't just, they didn't want to upgrade, because upgrading meant you had to rewrite the software for the newer system. So people continued to buy 1401, and IBM was like losing a lot of money essentially, right? But the problem is, you all know Moore's law. The compute power doubles every 1.5 years. It used to be 1.5, now it's 2 years. So it used to, back in those days, it used to be 1.5 years, which means if you are still buying a computer that was designed, let's say 4 years ago, you are essentially at least 4 times slower, right? 8 times slower, essentially. So what happened was, there was this other company called Honeywell, which makes a lot of other electronics these days. That company designed a new PC called the Liberator, and one thing about this machine was it was able to run the 1401's machine code in addition to its own machine code. So essentially people started buying more and more of these Liberator machine, and Honeywell was seeing sales. IBM didn't want to miss out on this, so they essentially wrote a virtualization layer for IBM 360 such that it can also run all of these 1401 and their previous offerings. So you don't really have to rewrite your software. And then this was the initial foreshadowing of virtual machines, if you will. And then the 90s happened, and in the 90s the internet happened, right? So just as soon as you had the internet boom, everybody wanted to have their own website. I mean, even the mom and pop stores actually wanted to have their own website, right? And so, but it was becoming very difficult, and it is still expensive to give someone a physical machine directly, right? Your physical machine would have a lot of space, and people would not end up like very small shops. People who are hosting a hobby project wouldn't actually exhaust that machine, right? So some companies came up with this idea of selling virtual machines. So people started selling this virtual machine, and eventually the companies like VMware popularized this concept called lift and shift in the early 2000s. So ops was a big headache for a lot of companies, right? So you had to, if a machine went out, you had to like physically replace a machine, and you just have to hope that somebody backed up the data in that machine, right? Because otherwise your data is lost. VMware popularized this concept called lift and shift, where you don't run your applications and you don't store your data inside your actual machine, but you do all these things inside a virtual machine. So anytime there is a hardware degradation or your hardware goes bust, you could just have VMware or your virtualization provider take a periodic snapshot, and you can just take that snapshot, put it on a new machine, restore it, and boom, you have this machine again, the same machine. So that was lift and shift. You don't really have to worry about your hardware failures and the hardware's the hardware's trustworthiness anymore, right? And then the later 2000s, you saw a lot of these VPS. How many of you have hosted a WordPress blog in 2000s? That was 2 decades ago. Okay, no, okay, WordPress. Okay, I think it's a younger crowd. So, what did you guys do in 2000s? Like when you started, Ruby on Rails? Anyone? Heroku? Okay. Sorry? No, Heroku. When I started programming, there was Heroku. That was like what, in 2011? Yeah. So there used to be a lot of these companies that were offering WordPress hosting, and there were these companies like HostGator and Media Temple, which were selling virtual private servers, which were essentially virtual machines. They were just giving you virtual machines, and now that has slowly evolved into cloud. These companies like Rackspace and DigitalOcean and Linode, which I'm sure many of you are familiar with. These companies were initially just VPS providers, and then they they did some R&D and they became cloud providers now. So that's the brief history of virtual machines till 2011, let's say 2011-12. That's what you were using virtual machines for. But then containers actually had a very parallel growth story. The first rudimentary container-like thing that went into that came out was this command called chroot. What is chroot? How many of you have used chroot? Anyone? So for the rest of you, chroot is something where you can change the root file system of your machine. If you do chroot and if you give it a directory, you all know the root file system in Linux, right? So the root will have a specific structure, and all your processes actually adhere to that structure. Your processes go to /proc, they read the temp files from temp and all that. So if you want to change the way a specific process behaves, all you have to do is create another directory on, let's say, your home directory or your downloads documents directory, and you can have the same structure /temp /bin /proc, all those structure, and then you can do chroot of that directory, and then you can, if you execute a command, the process will behave as though that directory that you created was the root directory. That was what chroot was doing, and chroot is like really old. If you look at this excerpt from the man pages, chroot went into BSD in 1982, which is like 5 decades ago. Containers, like the rudimentary implementation of containers, is like that old. And then, so when you talk about Linux containers, there is no such thing called a Linux container, to be honest. There is no lib container, right? There is no sys, there is no create container system call. There is only cgroups and namespaces. And cgroups was something that Google designed in 2006, 2007. Google designed, and they had it merged with the Linux kernel. Essentially what cgroups does is you can use a cgroup to specify how much RAM and how much resources, any kind of resources, how much of any kind of resources a process can use. That's what cgroups does. Namespaces is something that came from, I was told it came from Plan 9, but there are other operating systems where it predates. Other operating systems had namespace even in the 90s, like Solaris, for example. So namespace is something where it is similar to chroot. In case of chroot, you were able to say what file system the process should look at, right? You are able to basically fake the file system. With namespaces, you can do that to a lot of things, like the network, the ITC. You have like 6 or 7 namespaces. You can use that to fake your namespace, what the process saw, essentially. So these two things put together is what a container is made of. So there was this interesting project in 2010, 2011 called LXC. It used cgroups and namespaces to basically give you a virtual environment without using any hypervisor, without using virtual machines. You could do LXC, create a container, Linux container, and you can just SSH into that container and start doing your work. But it was not used in DevOps. So if this is nothing new, so what did Docker bring to the table? You already had the ability to achieve process isolation with just LXC. LXC is a project that predates Docker, and you were able to achieve process isolation using cgroups and namespaces, which are kernel features. So what exactly did Docker bring to the table?
Is that a question?
No, it is a question. I mean, but I just gave the answer. Sorry? Yeah, that is true. But more important than that, I mean, easy is very subjective, right? Easy is very subjective. But yeah, it is in fact easy, but it's very subjective. Compared to LXC, I wouldn't say it was that much of an improvement. And there is this tool called Vagrant. It had basically the same API as Docker. it doesn't use containers basically. So that is not, I mean, this is a Tyrion Lannister quote. He says this in the last episode of Game of Thrones. How many of you watched that episode? No one. Thank God. I would have felt sorry for anyone who watched. So Docker essentially sold the story of a box. So Docker, the way Docker was pitched, you were able to like picture you putting your application inside a box, packaging it and sending it to the ops people. They don't have to worry about what's inside it. And then the marketing pitch of Docker also involved this phrase called, but it works on my machine. Right? This used to be a big thing, I was told, before Docker. I was still in school, so I don't know. So it was apparently a big thing in large organizations where the ops guy says it doesn't run and the dev says it works on my machine. And there was one more thing that Docker actually brought to the table, in addition to technological improvements like copy and write file systems. There was one more thing that Docker brought to the table, which was the concept of application containers. If you think about it, in LXC, even though your process isolation model was using C groups and namespaces, you were still thinking in terms of physical machines, right? You had a machine which had a full installation of Ubuntu or a full installation of CentOS, and you were configuring things inside that. But when Docker came out, Docker said you don't have to think about your containers as systems, you just think about them as applications. So they popularized this concept called application containers. So this is what Docker brought to the table. And since people liked the story, it kind of, you know what happened after that. Everybody started using Docker.
But essentially, so they still use the OS underneath.
Sorry?
The Docker container also uses an OS underneath, right?
Like inside the container?
Yeah.
When you say OS, what do you mean? According to me, the OS is the kernel, right? The Docker containers don't have a kernel. The Alpine and everything, that's only the file system, right? That's only a set of files, the same kind of files that you would have on your root FS, right? When you do a CD root, it is the same thing. It's imagine if you copied all your root, if you copied a directory similar to your root file system, does it mean you created a new operating system? No, right? So that's kind of like a gray area, like what an operating system is not very clearly defined.
So we came to the idea of the rights. We have immediately used.
Sorry?
So we have this upper right.
Yeah, hub. I mean that was also nothing revolutionary because, like I said, Vagrant had it, and even before that, you essentially went to some place like DistroWatch and just downloaded your image. There was the CentOS, OpenSUSE build farm where you had all the famous Linux distros continuously building, and if you wanted the latest version, you just go to their build farm and just download that. There was nothing new. What was new was the story of box, because segue, and you suddenly had a way to you build all these, create all these containers, but how do you manage them? You need something to manage all these containers, right? So Docker came up with this implementation called Docker Swarm, which didn't take off all that well, mainly because of Kubernetes. Kubernetes is an implementation of a system called Borg. There was an internal Google system called Borg, and like I said before, Google actually pioneered a lot of these system C groups and those kind of concepts, right? So Google was using containers even before Docker came into the picture. So Google had this whole system in place already, and so a bunch of people inside Google, they just didn't want to release Borg directly to the open source world. So they made some changes, and then they released this project called Kubernetes. So the way to think about Kubernetes is to think of it as a data center operating system. Think of your entire data center as a single computer, and Kubernetes is your operating system. Because what does your operating system actually allow you to do? It lets you create processes, it lets you manage processes, it lets you manage data, like read and write data from a persistent store, all of which Kubernetes actually lets you do, right? So that a good way to think about Kubernetes is as a DCOS. And in fact, there is a competing implementation of Borg called Mesos, and the company behind Mesosphere, actually have a product called DCOS, Data Center Operating System. In fact, when Kubernetes first came out, it used Docker underneath. Sorry? Docker, the whole Docker. So we'll talk about what's underneath the kubelet. So when you do kubectl, so how many of you have used kubectl to run containers? So how many of you prefer to use the UI to load the YAML, do that? Kubernetes UI? No one? Nice, awesome. That's actually a better way. I meant the kubectl. So when you do kubectl, some command, this is generally how it used to happen when Kubernetes first came out. So you send a command, you say Kubernetes create this or run this, and then it goes and talks to Kubernetes master. Kubernetes master talks to kubelet, not directly, but let's blur that out. Kubernetes master talks to kubelet, and then kubelet uses Docker to essentially run your containers. This used to be the case. So and Docker, the command Docker, that is not responsible for running your container. There used to be this daemon called dockerd, there still is. So this dockerd essentially used to use LXC to start your container. But then this LXC, like I said, was created for a different purpose, system containers, and it was a binary in and of itself. So Docker people didn't want that. They created this runtime called runc, which was much simpler implementation of C groups and namespaces. So this is how it was working. They just replaced LXC with runc, and runc was a better implementation. And then what happened? They replaced runc. They took runc and they divided that into multiple projects called containerd, OCI, and basically they took dockerd and they expanded that into multiple products, multiple sub-projects. The reason this happened was there was this other project called, there was this company called CoreOS. They came up with a competing container runtime called Rocket. And Rocket was much simpler. It did not have all the baggage that Docker had. So CoreOS also had an implementation of Kubernetes that used Rocket instead of Docker. It was called Rocketnetes. So what happened was, now if you think about it, you have two competing implementations. You have two competing Kubernetes branches, right? So anytime somebody makes some change in the main branch, the Rocketnetes branch also has to pull that change, reconcile, look for merge conflicts, and do all that. So the Kubernetes people were like, okay, so if you both want to talk to me, I'll tell you how to do it. And then they released something called the CRI, Container Runtime Interface. And naturally, containerd did not adhere to CRI, the interface. And so they wrote a shim, which is basically an adapter between the CRI and what containerd spoke. So anything containerd spoke, this translation layer just translates that to CRI. This way, any runtime that speaks the container runtime interface can basically talk to upstream systems. So if you look at just Docker, this is how it is, right? It's the same diagram. I just removed the Kubernetes parts, right? This is your design of Docker. These are all the components of Docker. If you're on Linux, what happens if you're on Linux or Windows? Mac or Windows? Sorry? Yes, it runs from inside a VM, right? This is how it is inside your Mac or PC. It uses Xhive or Hyper-V, depending on which platform you are in, to create this mobile Linux virtual machine, and it runs the actual Docker inside that virtual machine. So when you do Docker PS from your command line, the Mac OS command line or your Windows terminal, what it essentially does is it pipes that command through a socket into Docker, into the virtual machine that's running the Docker. So that's why sometimes, how many of you use Mac or PC with Docker? Okay, enough people. So sometimes when Docker is not actually running, and if you try to do Docker PS, you would see unable to reach, is Docker even running, right? But if you look at this diagram, right, this Docker command line tool expects only this, right? Only the virtual machine, it expects to listen on some port, and it only expects this. So it can essentially live, the virtual machine doesn't have to live on your machine. It could be anywhere, right? In fact, there is an environment variable called Docker remote host, and you can set that to some HTTP, like some other IP address or some domain name, which speaks the same language as containerd, and it would just work. It would start spinning containers inside that machine. But like I was saying, this guy doesn't really know what is inside the machine, what is inside the virtual machine, right? This guy only understands Docker-D. So it might as well be an implementation that's altogether different, right? It could essentially be a black box. That's what this company called Giant did. So what they did, they had like a huge data center. They took their entire data center, they exposed an endpoint, they made that endpoint talk the Docker-D's language. And if you point your Docker remote host address to that endpoint, and if you did a Docker run something, it will create your container on their data center. So essentially, their entire data center became your Docker machine, your virtual machine, which is really nice. Sorry?
That's what keeps it like this.
Not really, but we'll get to that. I think I understand what you're trying to say. And it also does some other things, because if you run a container and if I do a Docker PS, I shouldn't see your container, right? So it also does some other authentication things and all that.
This is actually quite amazing, but the SAT into this whole Samsung and it goes the
Yeah.
internet of them.
Not really. They still sell to enterprise customers. They just close the public facing cloud. They still sell to enterprise customers, and Samsung.
From March of this year, they decided not to take any more.
I think Samsung itself is like a big enough customer, and if you think about it, they have sales and marketing expense for this. So why even bother? Yeah. So it's like that. So this is the Kubernetes half of it. Just like how you mimicked the Docker-D, the Giant people, if you think about it, they just made the entire data center speak Docker-D, right? You can have all of these layers do the same thing, right? Any of these layers, all of these layers have a clearly defined interface. You can have any of them, be mimicked, and that's exactly what they did. So I'm going to the previous slide. If you look at this is kind of ugly, right? Containerd was designed for Docker, and just because you wanted to make it talk Kubernetes, you have this new shim layer called containerd. And Red Hat has this Kubernetes offering called OpenShift. They didn't want to deal with these two layers of moving parts, so they had an implementation of CRI that was also OCI compliant. So they had one binary that spoke both OCI and CRI. So they named it Cryo, and then they released it. In fact, if you use OpenShift today, this is the default runtime that you get. And this layer is also clearly defined, right? This is OCI. Anything here will just expect the OCI interface here. OCI stands for Open Containers Initiative, but yeah, it only expects this interface. So whatever is underneath can change, right? So that's exactly what they did. So there was this project from Google called gvisor, which had this concept of sandboxed containers. What it essentially did was it took your container and put it inside a sandbox where you had a user space kernel, and anytime your container, a process inside your container, anytime it was sending a system call, your user space kernel would intercept that system call and would decide what to do with it, either to propagate downstream or propagate, deal with it on its own. It will do that. That's what gvisor did. And there was this other project called katacontainers. So the thing about gvisor is, since it was a user space kernel, it was not able to capitalize on any chip specific Intel or architecture specific virtualization instructions. There are instructions on your processor that are specifically used for virtualized workloads. So since this is a user space kernel, it was not able to do all that. It was essentially emulating the whole kernel as a process. So there was this other project called katacontainers. So like I was saying, just like Joint, there was this other company called hyper.sh. So they basically had a CLI tool where they had the same interface as Docker. You could just do hyper run a container and it would just deploy that container on a remote server somewhere, and it will just give you a URL which you could use to access your microservice. So, and they also went out of business. I think that's a pattern. So when they went out of business, they donated their implementation called runv, just like the original guy is called runc, right? So there was this other guy called, their implementation was called runv, their OCI implementation was called runv. And Intel parallelly was developing this project called Clear Containers. So they merged these two projects into one, to a project called katacontainers. And katacontainers, what it does is, it runs your container inside a VM. And these VMs are lightweight comparatively, compared to your, the standard VMs that you have in VirtualBox, those kind of VMs. These are comparatively lightweight because they don't pre-allocate resources. When you start a virtual machine on, let's say, VirtualBox, you pre-allocate 512 megabytes of RAM or 4 GB of RAM, depending on, you do all that, right? So these guys, they don't do that. They basically expand the virtual machine size as and when they need. This guy, katacontainers, still uses QEMU, KVM for virtualization. So this is why does this project even exist? Why do you need something like gvisor or katacontainers? So you have shared devices. Even though you are achieving process isolation, your container, let's say he's running a container and I'm running a container, they still exist on the same machine, right? He cannot look at my process, but he can still do a lot of things to damage me. He could just keep doing fseek, and then my disk read time would be bad, right? There is that. And then your Docker containers are not just your C groups and namespaces, they also come with seccomp profiles. The thing about seccomp profiles is it's actually a blacklist instead of a whitelist. So if you need to basically add all the system calls that you need to block, which means if Linux actually introduces a bunch of new system calls, your blacklist won't have them. And the rate at which the system calls are growing is pretty steady. When Docker first came out, the number of system calls was 200-ish. Now it's like 318. So it kind of went up by 50%. So all these old seccomp profiles are vulnerable now, right? So you have this problem of growing system calls, and then you still have, like I said, you have shared kernels, and the kernels would have other vulnerabilities, right? So anybody, let's say he's running his container, he wants to do some malicious things, he can exploit that kernel vulnerability to get to my process, right? All my data is also at risk. So if you're running some, let's say you have some business where you're running other people's containers, this kind of makes things very difficult. If you're running something like Firekube, let's say, you cannot confidently place my container and his container in the same physical machine, right? And then you have the problem of noisy neighbors, which is very similar to the fseek problem, where one container gets a lot of network calls, and the other container is forced to compete with that network traffic. The latency will become high, the download speed will become lower, and all those problems, right? And then there are certain classes of workloads that are just plain to run inside a container. War story. So we were trying to, for a very long time, we were trying to run Google Chrome inside a container because we were a crawling company, right? So all these PWAs and JavaScript heavy sites like Flipkart, they are notoriously difficult to crawl. It's like an actual application inside your web browser, and there is no way. If you just go to if you just curl that page, you will have no information, right? So you will have to actually render that page. So we used to run a Google Chrome. We used to have a Google Chrome instance farm, and then this predates Puppeteer. So we had our own wrapper on top of Google Chrome, just like Puppeteer, something that you can hit using an API, which exposes an API with the data, so you can just hit and get your data. So this is something that you cannot run inside a container. So in fact, we had a Mesos cluster specifically to run this outside of a container. Because Google Chrome expects your device. I'm not sure if this is still the case, but until even a year ago, even 6 months ago, Google Chrome actually expects that there is a physical display device in order to render. So you need to basically you need to mount. Even if you mount all your fake devices, virtual displays, it doesn't actually take. When Puppeteer first came out, if you look at all these old issues, it was a bunch of people trying to run Puppeteer inside Docker. No, Selenium and Google Chrome, I mean Puppeteer, they don't work the same way, right? Selenium only runs a JavaScript engine. You need a headless. Yeah. So a lot of these websites actually, in order to prevent people from scraping data, they actually try to find the size of your screen. So if you run a headless, your size of screen would be 0, so they won't let you crawl. Not in headless. So you need a virtual device. Maybe it has changed now. Like I said, this is an old project.
Actually getting tax data.
No, not now. Like I said, this is an old thing. Tax data is like pretty simple. We don't even use Google Chrome. It's just a plain page, easy. We just use normal curl kind of scraping. We just programmatically use whatever. We use Scala. We use an Akka cluster to just scrape data. This is easier because the hard part is not that, right? The hard part is inferring the data in that. So we have an ML team that infers, segwait. So there are workloads like this that are notoriously hard to run inside a container. And then there are large existing applications in companies that cannot easily be containerized, right? So a lot of projects actually address this. There's this project called kubelet that deals with moving your existing workload to Kubernetes. So it was a compromise. So if you want speed and density, like startup time and density, you have to go with containers. If you want security and isolation and real isolation, you have to go with virtual machines. It was a perfect balance, right? You know your choices. But then this happened. So AWS released this thing called Firecracker. It was a year ago at reInvent. And look at the things that they, in fact, before that, this paper came out. My VM is lighter than your container. And in this paper, the researchers actually described how they are able to achieve high density and low startup speed in a traditional virtual machine. So this is what Firecracker gives you. It gives you thousands of containers per host, just like Docker. Very high density. It gives you, It gives you 150 millisecond startup time, just like Docker. It's like, maybe it's not as fast as Docker, but it's negligible difference. And it also gives you real isolation because it's a virtual machine, and it runs on KVM. The way, so in this paper, like I said, the researchers were detailing the way they achieved this whole thing, right? So the way they achieved this was they stripped down the device profile. When you actually boot, so Linux has this thing called KVM. If you enable KVM, your base operating system becomes your hypervisor. So, and any execution that you do through KVM goes to your virtualization instructions in the processor. So KVM handles your virtualization for you. But traditionally, when people use KVM, they also use this thing called QEMU on top. QEMU is something like VirtualBox. QEMU also has the type 2 hypervisor, where QEMU doesn't use KVM and it emulates everything. But even when you use QEMU with KVM, it does all these boot sequence dance and device profile initialization and all those things. That's why even if you use QEMU KVM, your boot time is like somewhere between 1 and 2 minutes. So they removed all these devices because now you know what your workload is. Remember when Docker popularized the container, application container? So now you're not running systems, you're only running containers. So now only your application is going to reside inside your virtual machine. So you could get rid of all these devices. So that's exactly what Firecracker did. They stripped down all these device profiles, and they also, since you don't have these devices right now, you also don't need the drivers for these devices. So they don't need to be initialized. Your overall footprint is very small, and usually it's these drivers that expose vulnerabilities, right? You install a new device driver, God knows who checked the code for that, and suddenly your system is vulnerable. So now you don't have devices, you don't have to worry about device drivers that are bad. And this is also a pro. Apparently it is written in Rust. Rust is inherently memory safe and also inherently full of drama. So you cannot have usual causes of vulnerabilities where somebody tries to use memory after free. So that's one of the primary causes of vulnerabilities. And since this is written in Rust, you cannot have that. So remember this old diagram from few slides ago. So how do you use Firecracker in this? All you have to do is just there was this place, katacontainer was using QEMU KVM. So there is an adapter layer where you can use Firecracker instead of QEMU KVM to run your containers. So this way your katacontainer deals with translating between the Firecracker API, and katacontainer does the OCI upstream translation. It deals with all the OCI, exposing all the OCI related information. So this is not like the only project. There are also competing implementations of projects. I mean, there are also competing projects that use that use Firecracker to achieve isolation. Firecracker with katacontainers is what we saw, like in the last diagram. There is also a Firecracker containerd, which in this layer, instead of cryo, you have containerd here, right? So in that layer, you expose Firecracker such that just as soon as containerd is still an interface, right? Containerd talks to containerd also manages your containers, but containerd has to talk to someone to create the containers, right? So they just used Firecracker to create your workloads with your containers essentially, and every time the upstream system asks for PS or the status, the containerd-Firecracker project does all the translation. Underneath it will go do a PS from inside your Firecracker virtual machine, and then it will report those data back up. So there is that project. And then there are other projects that use Firecracker. One of them is vIgnite and Firekube. They are both very related. So vIgnite is a project that's more similar to Docker. So when you do a Docker run on your machine, it creates a container on your machine, right? When you do so, this vIgnite project has like the exact same interface as Docker, your Docker CLI tool. So if you do ignite run an image, what it will do is it will create a virtual machine, a very small virtual machine, your Firecracker virtual machine, and then it will install a kernel on that, and then it will install rootfs, and then it will download your container, unpackage that container, and start executing your workload. So, and then there is this equivalent to Kubernetes project called that uses Ignite called Firekube. So there are two use cases for Firekube. One, you could use it like Minikube. So if you remember from few hundred slides ago, your Mac actually uses Moby Linux virtual machine, right? So if you are going to run a virtual machine anyway, you might as well run one virtual machine per process, right? So Firekube competes with Minikube in that regard. If you use Minikube, if you do all your containers essentially run inside one virtual machine in Minikube, right? In Firekube, all your containers run in isolated virtual machines because they are small. They can afford to do that. And there is another use case where you could have Firekube spin virtual machines and then attach those virtual machines as kubelets, as nodes into your Kubernetes cluster. So that way you could essentially give, even though you have like one big physical machine, you could use Firekube to create 4 different or 5 different virtual machines and then have them all run kubelet, and suddenly you have 5 nodes. You could have that too. So I'm not the only one who is pitching microVMs. So the blog post in the background, that's from a principal engineer at Pivotal. So he's saying the future of Kubernetes is virtual machines. And the guy in the foreground, he is a principal engineer at Red Hat. He's saying Kubernetes will replace hypervisor. Essentially, he's saying Kubernetes is the future of virtual machines. So they're both saying the opposite of each other, not the opposite. The subject and the object are repeated. Essentially, Kubernetes is the future of virtual machines, and virtual machines is the future of Kubernetes. So they are made for each other, I guess. So they are both saying this. So why do you need all this? So why do you even need to care about process isolation and real security at all? I mean, if you are a PaaS provider like Heroku, it's pretty obvious. You cannot have my workload and his workload running on the same machine for all these vulnerabilities and security reasons. But what if you are only running a Kubernetes cluster internal to your organization? Even then, right, there are a lot of cases where somebody accidentally does something bad, right? They can accidentally forget to remove an fseek. All these things could happen when you have an organization that has like 4,000 people. This could very easily happen. So if you give them better safety, if you give them a floor to stand on, they would be more confident. So one of the first things that people told me when I joined Index right out of college, they told me no matter what you do, you cannot cause any damage. No matter what you delete, we have backup, we can bring it back. So confidently do whatever you want. So that gave me a lot of, I did not go deliberately delete something. If I wanted to cause damage, I would. I cannot accidentally cause a lot of damage that would result in loss for the company. So if you give your developers that kind of freedom, they would do better work. Yeah, so I guess, thanks, I guess. Yeah. Yeah, you can basically rate limit your VM, right? It shouldn't, because you can rate limit your VMs. You could, if there is one virtual machine that's pretty noisy, you could just isolate that VM and kick it out. You could do all that. Sorry? Containers you cannot do for fseek. You can do for all these other isolations. Other resources like CPU, RAM, and all these things you can do with C groups, but fseek you cannot. Basically, you cannot do anything about the I/O. That's the same case with even network, right? How do you stop this container from pulling too much traffic inside, or pushing too much? Either ways, you cannot do that. Sorry? Yeah, it will give you an equal share of CPU, but not the I/O. You cannot control the I/O, right? That's the thing. Yeah, I mean we can discuss that, but here this is the thing. Your C groups doesn't allow you to limit the I/O, and in virtual machines you could do that. And in Firecracker, in microVMs. So microVMs. So all the communication to your application running inside that happens through network, HTTP. Only network in that, and they have like a keyboard, like a device with one key, just for interrupts. Just to send an interrupt, like the kill signal perhaps. They have one key. That's all. No, you cannot do that. The only way to communicate with your application is through network, through HTTP. Not HTTP, it's TCP. It's not a limitation. If you think about it, that's how we do it in Docker as well. Obviously, you can know volumes and everything, but you don't do it that way. What you actually do is you talk through the expose TCP port, right? So that's the same idea that they have. So they remove all the devices so that they can force you to communicate with the device. Any other questions, guys? Okay. I'll tell you probably after the video is out. All right. Thank you, guys.